Refraction of light and optical instruments. Why does a stray stick partly immersed at an angle in water look bad? Why do the stars appear to twinkle? Why is the sky light appears before sunrise and after the sun sets? Can you explain why it happens, as already has been discussed in chapter 13, that light travels in a straight line while passing through a homogeneous medium? However, when a ray of light traveling through one transparent medium enters another transparent medium at an angle other than normal incidence, it undergoes a change in direction. The instants quoted above are due to the bending of light rays while passing from one medium to another. A variety of optical instruments such as cameras, microscope, telescope utilize lenses to make use of the phenomenon of refraction for a specific purpose. Refraction of light. When a ray of light enters from one medium into another obliquely, it undergoes a change not only in direction but in velocity as well. This change of direction and velocity of light as it enters from one medium into another is known as refraction of light. The refraction of light is explained in figure 14, in which AB represents a surface separating two media. When a ray of light CO passes from one medium into another, its direction AB changes to OE instead of OD. Point O is called point of incidence ray. OE is known as refracted ray. N1 is normal to the surface AB at the point of incidence. The angle between incident ray and normal C1 is called angle of incidence. The EON, the angle between a refracted ray and normal, is known as angle of refraction. It is discussed from experiment that when light passes from a rare medium to a denser medium, say from air to glass, it bends towards the normal figure, and when the light passes from denser to a rare medium, it bends away from the normal figure. When light enters from a rare medium to a denser medium, it bends towards the normal B. When light moves from denser to rare medium, it bends away from the normal. Refraction of light takes place under two laws known as laws of refraction of light. These are the incident ray, the normal, and the refracted ray at the point of incidence all lie in the same plane. The ratio of the sine of angle incidence 1 to the sine of angle of refraction R is constant for all the rays of light passing from one medium to another. This constant is called refraction index. The constant quantity in its own known as the refraction index of the second medium with respect to the first medium. It has no unit for a ray of light passing through the surface separation of two media. The angle of incidence is 0 and the sin is also 0, as sin therefore is also 0 because n is constant. N is not 0. This means that if a ray of light is incident perpendicularly on the surface separating the two media, the refracted ray shows no change of direction. When light from the air enters water, it bends towards the normal due to refraction. Similarly, light coming from underwater bends away from the normal in the air due to this bending effect, a pebble lying underwater does not appear at the same position where it actually is from above. The rays seems to come from a point which is not so deep and is slightly to one side. So the pebble seems closer than it actually in figure 14.3 because of this object seems larger underwater. Refraction index. The refractive index from of a medium does not depend upon the angle of incidence, it depends upon the nature of medium. The refractive index of a medium may also be defined as the ratio of the speed of light in vacuum to the speed of light in that medium. As the speed of light is in vacuum is almost equal to the speed of light in air, therefore we use the speed of light in air instead of speed of light in vacuum while calculating the refractive index of a medium. For example, the velocity of light in water is 2.26 multiplied by 10. The angle between the two refraction rectangular surface opposite to the base is called the angle of the prism. Shows be the path of a ray light through a triangular prism. The ray EF strikes the face AB of the prism. On entering the prism, this ray bends toward the normal OL at the point of incidence, that is, it bends towards the base BC of the prism. The refracted ray FG on emerging out the prism further bends away from the normal PQ at the point of incidence, that is, the emergent ray GH bends further toward the base of BC of the prism. The angle EFO is the angle of incidence, angle LFG is the angle of refraction. If the incident ray EF is further extended up to the point K and the emergent ray is traced back up to the point M, then the angle KMG is called the angle of deviation, that is, it is the angle between the extant incident ray and emergent ray. The value of the angle of deviation varies with the angle of incidence. It may be verified experimentally that the angle of deviation is least when the incident ray and emergent ray make equal angles with the normal, that is, when the refracted ray is parallel to the base BC of the prism. The minimum value of the angle of deviation is called the angle at minimum deviation and it is denoted as D.